setting up OpenCV to work with a third-party HAR cascade to do something like this. Yeah, sure, this is actually a little bit silly, but the idea here is to actually get a third-party HAR cascade working with our system. Now, I do recommend that you go through our last video, which is on overlay and watermark, prior to jumping into this one. It gives you a lot more context, and you can find that at this link here. And then I also wanted to mention that finding third-party HAR cascades sometimes is just a simple Google search and looking for HAR cascades, OpenCV, and then you should find some XML documents, much like what you see on this page. And then you can also find a lot of tutorials that actually cover these HAR cascades and implementing them as well. And we took some inspiration from this post, so I do recommend that you check that one out, although it does show a little bit more advanced ideas for this than what we're going to do. Ours is just going to be slightly different from that one. And it's going to be based off of more of what we did in the overlay and watermark section. So if you want to get more advanced stuff, just check out that blog post after you go through this. So the next thing is, I do want to make sure that you go to joincfe.com/GitHub, go to our repo for the OpenCV Python series, because this is where all of the final code will be. And it's also where our third-party HAR cascades that we're using are, as well as the images that we're using. So if you go into the SRC folder here, you'll see the cascades, into third-party. You'll see the images inside of fun. Those are the images that we'll be using. And then finally, you'll go ahead and jump into glasses_and_stash. That's what we're doing. And then you'll see exactly the setup process at the very top. So you're going to want to copy and paste at least that portion so you have your code looking like this. Of course, there's a couple important things to note. Number one, we are using a utility that we've created, and it's in our utils.py file. So yeah, you're going to want to definitely have that too. These utilities just make it a little bit easier to work with our video capture and frame and just changing the size of things, as well as resizing the frame itself. So the next thing is we're going to be writing a video based off of those dimensions and how we set those things up. And then finally, we have those third-party cascades already loaded in. And we also have our images loaded in using -1, because we want that raw image with the, the transparent backgrounds, because we're using PNGs here. Okay, so what we've done is nothing really new. Hopefully it's nothing really new to you at this point. If it is, then you might want to go back. I have to say that several times because often I'll get questions that are related to not going back. Sorry for those of you who've heard me say it 100 times and you're over it. So let's go ahead and first and foremost convert our frame into grayscale. Now this is something that's very common when we use cascades, is you convert the color into grayscale. So we do our frame and then cv2.color_bgr to gray. And with that grayscale, we're going to grab our faces, or the faces that are actually matched in here. And that's of course using the face cascade. And we're going to go ahead and detect multi-scale of that grayscale. And you can add in something like a scale factor, and I'm going to use 1.5. You might use 1.3. Playing around with these parameters is something that might give you better results too. So feel free to do that. So minimum neighbors, I'm going to use 5. I actually believe those are the defaults, but I wanted to mention them in case you may have forgotten. Okay, so now the thing about this faces is this will actually detect where all my faces are in this frame. We could test that out simply by doing for X, Y, W, and H in faces, and we can look for our region of interest. So the region of interest, of course, is the person's face. So like ROI, region of interest, gray would be this area in the gray frame, or also in the color frame. So we can have both of them. And actually, you want to use both of them for the cascades that we're about to do. So I definitely want to have, starting at the Y point, so the very top of the Y, and going to Y plus the height. So this is grabbing those values, or those actual pixel values, inside of this NumPy array, which is what is happening here. So these are actually NumPy arrays. So when it's reading it as a NumPy array. And then we're going to get the same thing, but the X values, just like that. So this gives me a rectangle of some kind, right? So a rectangle, it might be a square. It's probably not because it's going off of my face. So more than likely it's going to be a rectangle. If you have a very square face, then there's a chance that it might be square. So we have the ROI gray, and that gives me that section. That exact same section in color is quite simply, we just change it to using color, and instead of gray, we just use the default frame, because of course the default frame will have it in color. So now that I've got this, I can actually go ahead and use my detection for other things such as eyes and nose. And again, we are using these third-party cascades, but it's not any different than the built-in ones. The third-party ones, I mean, they look the exact same. If you go through them, it's like, okay, well, there's some values that I have no idea what's going on, but it shows me the cascades themselves. Okay, so we can do the same thing as we did here, except we want to change what the variables are in this for loop. We absolutely want to change that. So the first thing I'm going to do is the eyes one. So I'll say eyes equals to eyes cascade dot detect multiscale, and I'm going to go ahead and grab this whole area here, just like we did with faces. But instead of grabbing the entire gray frame, which you could do, but that takes a little bit more processing, we just want to grab the region of interest. So that's our region of interest now. And then from here, I can iterate through that same area. So where it starts, and then also the width and the height of it, which gives me where it ends. So EX, and then EY, EW, EH in eyes. So why am I doing an EX? Well, it's mainly for me to say, hey, the eyes, the X value of the eyes, the the Y value of the eyes, the W value of the eyes, and the height value of the eyes as well. So that's what that's doing. It's giving me a very similar thing. It's giving me another region of interest, right? So I can say the region of interest eyes equals to this new region of interest inside of my frame. So I could do gray and grab whatever that region of interest is. So I could also do ROI gray, because this is a sub region of interest of that region of interest, right? So that's probably actually the better method of doing this, is because that's what we're using. We're using ROI gray anyway. So this would give me the region of interest in these region of interests, right? So if we think about this on a bigger scale, all of these are doing is giving me a region of interest in the frame region of interest. The frame is our now region of interest, and we're doing sub-regions in there with this. And since we're detecting from a sub-region, we also probably want to grab that sub-region here. So ROI gray, and this is going to be basically this area again. So EX to, or sorry, not EX, but EY is to EY plus EH, and then comma, EX is EX plus EW. So it's roughly the same. So this is the actual rectangle that will be around those eyes. Fairly straightforward. We still have some things that we need to do in here, but before I do that, I'm going to go ahead and copy this and grab this same concept for the nose. Right? So my actual nose, using the nose cascade. It's not a whole lot different. And so now we just do nose, and then we say nose. And then now, instead of EX, I'll do NX. Oops, not MX. Little typo there. NY, NW, NH. And the same thing for that region of interest. If we were to need this region of interest, which maybe we do, maybe we don't. But the point is, I just wanted to show you it. And it's still the ROI gray. And then again, we want to change these values in here as well. It's, you know, little tedious here and there, but the point is to make sure that we have everything set up in the way necessary to build whatever we need from here. So I now detected faces as well as regions of interest. So this is where I can append things like an image or something like that. what I'm actually going to do is first draw some rectangles so we see that these region of interests are actually working. So cv2.rectangle for our faces, and that's going to be frame. So we're taking the frame and then the values of where these things are located. So of course it's X and Y here, and then the end value. So X and Y are the starting points of the X and Y axes, which I'll point out when we get there. So then we need to get the end value of that, which is X plus W and then Y plus H, right? And then we want to set some sort of color out of 255. So 0 out of 255. So I'm just going to do 255, 255, 255. And then we will use the number 3 for the stroke width. So that will give me a frame around the face. And we're going to do something similar for the frame around the color, just adding E to all of those values. And I'll change the color a little bit here too, just so we can see the differences in all of these. And then finally, the one around my nose. Actually, I'm going to use this same frame from up here. Make it a little bit easier when changing everything. So change this to N, 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 and so on. So this should actually draw the colors as needed and the frames around them inside of my frame. So the actual frame that I'm showing, it's going to show it there. I actually have the rectangles in the wrong area. I should be putting it in the region of interest for those sub items, because again, where it's detecting from that region of interest. So I need to use the color version of that region of interest. Otherwise, it's going to be in the wrong place. It will still be putting it somewhere. It'll just be in the wrong place. So you definitely need to make sure that you keep an eye on where you're drawing or going off of these region of interests. Otherwise, you'll have some problems. Okay, so let's go ahead and jump into my PowerShell. And I'm going to go ahead and run Python glasses underscore and underscore stash dot py. I'll hit enter. And hopefully what I'll see is a square. And there we go. So we've got a green color being around my eyes, the white color around my face, and the blue color around my nose. It's accurate. So again, I mentioned that these region of interests, if they're wrong, let's just do it on the frame. We'll see exactly what that is. So it's still recognizing that they're there, but it's putting them in the wrong place. And that's because of how the relative region of interest works, or how the relative like cascades are working. It's just going smaller and smaller, which means that it doesn't have to do as much processing, which is part of the reason we did that. Okay, so now that we have these things, how do we actually add these images that I've created on them? Well, this is where the tricky part comes in, and where the last video is really, really important in how this works. So the first thing that I need to do is I need to create my frame to have an alpha value. So the reason for the alpha value is to make sure that I can use the alpha value of these, as in the transparent value, whatever that transparent value is. I need to be able to make sure that I use those for my glasses and my mustache. Otherwise, I'll get this like white box around them. So I'm not going to do that. I'm not going to show you the white box. I am just going to assume that you don't want that white box, so we're going to go ahead and get rid of it. If you don't want, or if you are okay with having the white box there, or basically not allowing for transparency, then you can ignore this. You don't have to like have the transparency, but we want it. So I'm going to go ahead and do cv2/convert color, and it's going to take in the frame, and then it's just cv2 color underscore BGR to BGRA. And since we're doing that with the frame, I'm going to start it that way. But before I actually write the frame and view it, I'm going to change it back. So BGRA to BGR, we save that. So this changes it to BGRA. Then we can do some processing stuff, and then I change it back to actually write it out. I believe this is also what you would have to do to actually store a grayscale image or grayscale video too. So definitely check that out or try that out too. Okay, so now that I've got this, I'm going to go ahead and comment out my rectangles. I no longer need those. But what I do need is I need the various things, right? So I can assume that my faces are going to be identified. So now I want to put the glasses over my eyes. That's what I want to do. So to do this, I'll just say glasses equals to, well, I want to actually resize the glasses images. And that's this right here. I want to resize it based off of my eyes. So if I'm really far back, it will actually update that. If I'm really close, then it'll update that as well. And I'm just going to say glasses. So I pass in the glasses, and then a width of what I want to use, which in my case is EW. So it's the width of these eyes. So what that method does is something that we created for you, is it will actually auto scale these when necessary. And this auto scaling will allow for it to not be, distorted at all. That's kind of the idea here. It's just a convenience method to make it so it doesn't distort. So now, remembering back to the overlay and watermark video, you might remember that we need to grab the shape of these glasses. So I'm going to say GW, GH, and GC equals to glasses.shape. So GW as in G width and GH as in G height. We're going to iterate through every single pixel value in this glasses image. And then we're going to replace it with the color, right? So the ROI color, we're going to replace those pixel values. So I'm literally replacing individual pixels from one video with the individual pixels from the actual image. Now, this is definitely not the most efficient way to do it. It's a way that works, and it's a way to show you how this is done. It's not so much to be the best way possible. That being said, that blog post I mentioned about the nose mustache stuff will show you another way of how to accomplish this too, which I believe is more it's more efficient than what I'm about to do. So I'm going to go ahead and iterate through for I in range of 0 to the glasses width, and then I'm going to iterate through for J in range from 0 to the glasses height, and then I'm going to say if glasses of I and J is not with the third element is not equal to 0, then we're going to say ROI, oops, we need to put a colon here. Then we're going to say ROI color of where this is, which is going to be the EY, so the location from EY, plus I, and EX plus J equals to the glasses of I and J. Okay, so I'll go ahead and print out the IJ values so you can see what this is all about if you did not go through that last one, as in the overlay and watermark one. So what happens here is when we get the actual third value inside of this list, if it's 0, that means it's an alpha of 0, which means we want it to be transparent, which means we don't need to change that pixel. We don't need to change that pixel value in our ROI. Okay. So that's going to do my glasses. Let's go ahead and try it out. I'll print out the glasses. It's going to be a little laggy at first, so I'll just show it for a second. It's very laggy actually. So I close that out. And what you see here is all the zeros, or if I scroll up quite a bit, because it actually processed things pretty quickly. All right, so it's showing a bunch of zeros. It actually doesn't show me the history, but essentially it's the RGBA values, and getting the third one will grab me that alpha value. So I'm not going to print those out. That makes things a lot slower. Once you print out anything inside of each frame, it makes things a lot slower. And contrast that also with these iterations. It's going through a lot of iterations here. So I can actually take this same idea and apply it to my nose and paste down here. So no longer is it image resize for glasses, but rather for mustache. And make sure you're in the nose. And then the width is going to be based off of the nose width. And then we just are going to change from glasses and the MC stuff, GH, to just M, just adding M's there. Everything else is pretty much the same with the exception of this right here. So there's going to be no NY and NX. So we save this, and we will have to think about how this is going to run, but I'll go ahead and save it and go through it. Because if you remember, what did the box look like for my nose? Was it below my nose where a mustache is? And I actually have a beard, so it's kind of hard to tell exactly, but the nose itself was actually around my nose. So if I look at this now, I actually have my glasses, or the glasses are showing up again, not the mustache, and that's because I think maybe, oh yeah, I used glasses here, so it should be mustache. There we go. Maybe you caught that, maybe not. But what we'll see is the mustache is on my nose. So we want to move it down. And we want to move it down relative to my actual nose size. Another thing is that you might notice is the mustache seems to be being weird. So I'm just going to use copy, and I'll do the same thing with my glasses. So this actually copies the instance of the original one. It will copy that. To make sure, we just put a new item here and do glasses 2, and then it's taking off of the image shape there. So again, mustache 2, the original shape is fine, and then we just bring this down here. That's just to make sure that we're not resizing the same image over and over and over again. Okay, so I need to change where that mustache exists, or where it lives on my face. Oops, we got a little error here. So it's possible, let's just make the mustache 2 shape. That might be giving us that error that I just saw. So I will go off of the actual resized shape. That's probably better anyway. I should have realized that when I said that. Okay, so we want to move the mustache down. Okay, so that means I need to add some level from my mustache height, right? So what is going to be that actual level? Well, it's actually going to be off of my nose height. So whatever my nose height is, I'm just going to take whatever that half value is and add it to where I put this region of interest. So it's going to be roughly the same all the time. So I'll just go ahead and do an int of nose height divided by 2.0, save that, and we'll try this again. Let's run it. And now it's down below. It's not perfect, but it works. And it shows you exactly what it is that I was trying to show you, which is using these third-party hard cascades and doing it with something maybe somewhat fun. I mean, it's like how often are you going to use something like this? I have no idea. But you'll definitely use third-party packages in some things beyond just this. And the idea is also to get used to playing around with different methods of replacing actual pixel value on your frame. And that's exactly what we did here. So if you have any questions on this, please let me know. I think that this was fairly straightforward from what we did with the watermark lesson, but for those of you who didn't follow along with that or just wanted to see it in action in a different way, this was the purpose. So the thing about seeing it in a different way is the watermark stayed in one spot, right? It was down over here. These will follow me around. I mean, and if I had other faces on there, it would add to those faces too. So if you had a picture, if you use this as a picture instead of a webcam, it will add it to multiple faces, which is cool. And I recommend that you try that out. The other thing that you might note is, doing this in a live video feed, my mustache seems to add 2 of them. And that's just a challenge that you would have to come about. And then my glasses, maybe they're a little bit small, or maybe all of these things are a little bit small, so I want to make them just a little bit bigger. So the width, I could change it being just slightly bigger, or I could do it based off of, some other aspect of this. Like, you could absolutely change the sizes of these things if you were interested in that, right? So if you wanted to, you would do something like int EW times 1.2, and let's try that one out. So this should make my glasses just a little bit bigger, and there we go. So now they're a little bit bigger. Obviously the width and height and stuff are just a little bit off, so I'd probably have to adjust how all of this part works, much like I did with where the nose scale is. But I'm not going to do that. I think you have enough skill here now to experiment on your own. So if you have any questions, please let me know. And if you are interested in getting a lot more from OpenCV and Python, be sure to subscribe on joincv.com/YouTube, because we will be posting a lot of things on OpenCV and Python as I get better at it. I'm still mastering OpenCV and Python myself, which is why I'm putting so much of this stuff on YouTube, because this actually helps me learn a lot. I get questions from you guys, I get suggestions from you guys, but then I also do my own research, and I find interesting things that make me better at doing OpenCV. So if you find stuff that you want to share with myself or with everybody else, please let me know in the comments below, because I am interested in doing a lot more with OpenCV. It's a very fascinating subject, is what I find at least.